Good afternoon, Shadows, and welcome to Blur's Day Virtual Academics. I'm Captain Black, and a big thank you to DOW for letting me host this week's academics. Today we'll be discussing bombs. Today's objectives are 1. List the 4 components of a bomb. 2. Summarize the use of a fuse. 3. Compare and contrast unguided bombs and precision-guided munitions. And 4. Name a mission planning tool to use for lethal effects for bombs. Now, some of these definitions may be unfamiliar to you, but don't worry, we'll go over everything during the lesson. Here's an overview of what we're going to cover. There's 4 main components of a bomb. The bomb body, so the size and the shape. The explosive filler, or what material is going to make it go boom. The fuse, so how is it going to detonate that material. And then the tail, so how is it going to guide the weapon to the target. All right, so the first component is going to be the bomb body. So the bomb body is usually referred to by the weight or the size, and then the type or the shape of it. So as you can see on the right-hand side, you see the top weapon is called a Mark 84, and then the bottom weapon is a Blue 109. Now the shape of the Mark 84 is a little bit different than the Blue 109. The Blue 109 is a penetrator, so it's meant to go through reinforced concrete or bunkers, whereas the Mark 84 is a general purpose bomb. So this bomb body will serve as the basis for several of the weapons in the precision-guided munition categories. So on the left-hand side in the chart, looking at the bomb bodies, the 500, 1,000, 2,000 pound weapons, you have the Mark 80 series. So 82, 83, and 84 to the appropriate weight classes. And then the Blue 109 is also a 2,000 pound weapon, but is a penetrator as we mentioned before. The second component is explosive filler, and that can be TNT, tritonyl, or some other sort of explosive material. And this makes up about 30 to 40% of a general purpose bomb's weight, and then about 20% of a penetrator's total weight. The third component is the tail. So this provides stability in flight. The image on the right, upper right, is the tail, and then the lower right is a tail with a retarder on it, and this acts as a little parachute. So this is for low altitude employment to increase the drag on the weapon in order for the delivering platform to get out of the way before the weapon explodes. Lastly, we'll talk about fuses. Fuses are what detonates the explosive filler. So this can be placed in the nose and or the tail, and they can be mechanical or electric. We'll take the next couple slides to go more in depth into the fuse. Fuses cause detonation after certain conditions are met and at precisely the right time. The measurement is usually in milliseconds of the delay. As we can see in the upper right-hand corner, Wile E. Coyote is waiting for the door to open so that the lever can be pressed and the detonator can then send the charge to the explosive filler or to the TNT in this case. However, in real life, looking in the lower right-hand corner, we can see the FMU 139, and that's a fuse used for a bomb. So there are different settings on there which can have different instantaneous or millisecond delays that can then detonate the explosive charge in a bomb. One way fuses can be used is, let's say your bomb needs to punch through a lot of material and then detonate on the other side. By setting a delay with the fuse, your bomb can punch the material without exploding until it reaches the open space. So fusing is also important not only for selecting the correct millisecond delay for going after a target or to achieve desired effects, but also to make sure the weapon is safe. So fuses must remain safe while being carried on board and must remain safe until after the bomb is released from the aircraft. So think of this as a safety on your pistol. You want to make sure the safety is on unless you're getting ready to fire at a target. Next, we'll look at ways fuses can be used to achieve different effects in the battle space. A longer millisecond delay will allow for a very narrow blast pattern, and this might be used if there is something we do not want to hit around the target. A shorter millisecond delay does not allow the weapon to bury itself in the dirt and creates a wider blast pattern. Next is a demonstration of a proximity fuse. As shown, the airburst is able to provide a wide area of damage compared to the previous examples. In the video, notice that the Blue 109 has a delayed fuse because it explodes after it has penetrated through the reinforced concrete. Now that we've talked in depth of the four components of a bomb, we can now talk about precision-guided munitions. Precision-guided munitions, or PGMs, are also known as smart weapons. They can precisely hit a target while also minimizing collateral damage because of their accuracy. So PGMs have the same components of unguided bombs, including the bomb body, explosive filler, and fuses. The difference is the kits that are put on the base bomb body, so like the Mark 84 or Blue 109, help provide that greater accuracy. So these can be on the tail and the nose, or just the tail. The transition from unguided to guided weapons has allowed us to use one weapon for one target. Now, there are exceptions, but for the purposes of this lesson, think of this as one PGM can achieve the same effect and is more accurate than 19 unguided weapons to the same target. So how can we measure this precision on these weapons, specifically how accurate is accurate? And we can use a tool called circular error probable, and this is just based off of probability. So using the radius of a circle centered on the average, the boundary is expected to include the landing points of 50% of the rounds. To put it in simpler terms, if you have a CEP of 100 meters, half of the weapons you will drop will land within that 100-meter circle or 100-meter radius. It's important to note that CEP shouldn't be a hard and fast rule because of this is a probability. So think of this like flipping heads or tails on a penny. So we know the probability to get heads or tails is 50% because there's two sides. But if we were actually to do an experiment of flipping a penny 10 times, it wouldn't always come out to be 5 heads and 5 tails when we would flip the penny. The first precision-guided munition we're going to talk about is the laser-guided bomb, and it uses a EO sensor to guide the weapon towards the target. The big thing here is you're going to need a laser designator, whether that's a JTAC on the ground or some sort of laser on the ground, or a laser that's coming off a pod off an aircraft with a matched pulse pattern. Basically, is the encryption the same on the laser so that the weapon knows which laser to go to. As mentioned before, the bomb body, fusing, and explosive filler are going to be consistent amongst unguided weapons and PGMs. So that's no different here. So you can see the Mark 82, Mark 83, and Mark 84 in the upper right-hand image are all going to be the foundation for the GBU 12, GBU 16, and GBU 10 respectively. Just the tail kit and the nose are going to be a little bit different. As you can see, the nose it has that seeker, so it's able to see the laser in the terminal phase. Looking at the lower chart, you can see the conversion. The weight and the bomb bodies are still the same, but then the laser-guided bomb takes on a new nomenclature. So GBU, or Guided Bomb Unit, 12, 16, 10, and 24 to match up with the Mark 82, 83, 84, and Blue 109 series weapons. LGBs were very popular in Desert Storm. However, what would happen is some of the sandstorms would come through and they wouldn't be able to use lasers because the weather would essentially affect the seeker to be able to see the laser. Because of the lessons learned from Desert Storm with the inability to use LGBs during sandstorms, JDAM, which is Joint Direct Attack Munition or another form of precision-guided munitions, were created. So JDAMs use GPS or INS to guide the weapon, which makes it all-weather capable. As with the laser-guided bombs, the JDAMs have the same bomb body, explosive filler, and fuses. However, the tail kit is a little bit different as the tail kit houses the INS GPS receiver for the guidance system. JDAM nomenclature can be seen on the left. So if you have a Mark 82 bomb body with a JDAM kit on it, it becomes a GBU 38. Then a Mark 83 becomes a GBU 32, and then a Mark 84 and a Blue 109 becomes a GBU 31 V1 and a 31 V3 respectively. So sometimes for short you can just say V1, V3 if your platform carries both GBU 31s. So the last type of bomb I'd like to talk about today are called standoff weapons. So these are bombs that can be launched a significant distance outside the range of the adversary or an appropriate distance away that might be within the weapon's engagement zone of an adversary, but gives the platform delivering the weapon enough time to exit the WES before weapons impact. We have several standoff weapons in our inventory, and the two we're going to focus on today are the Joint Air-to-Surface Standoff Missile, which is the JASM, and then the Conventional Air-Launched Cruise Missile, which is the CALCM. The JASM has a range of 230 miles. What's unique about this weapon is in the terminal phase or the end state, it uses an IR seeker to do pattern matching against its targets. So the JASM was actually first operationally employed on 14 April 2018 against the strikes in Syria. It was actually used again on 27 October 2019 for the raid for Abu Bakr al-Baghdadi. The CALCM has two variants, the Charlie and the Delta. The Charlie is a blast frag, and then the Delta is a penetrator. What's unique about this weapon is the amount of flight time that it can have, sometimes hours long, with a less than 5 meter CEP. The overall advertised range for this weapon is 1,500 miles. We just spent the last several minutes discussing what makes up a bomb and different bombs in the Air Force's inventory. Now let's look at a mission planning tool called AFAT, or Access, Fidelity, Accuracy, and Timeliness, to discuss the lethal effects of bombs and also different considerations to look at when trying to employ different weapons. To illustrate the AFAT model, I'm going to use a straw hut as a target. Starting with access, this is where we ask the question, can the munition hit the target, i.e. the straw hut? So considerations include, can the bomb or the aircraft delivering the bomb reach the straw hut? Does the weapon need to have penetration capability? For the case of this scenario and the straw hut, the answer is no. Also, what kind of environment is the straw hut located in? Can the bomb and platform delivering the bomb survive that environment? Fidelity asks the question, can the munition achieve the desired damage or effect, and how many munitions are going to be needed to achieve that damage or effect? Continuing with the straw hut example, if the straw hut needs to be rendered unusable by the enemy, there's a possibility to drop 3 2,000-pound weapons on the hut, making it scorched earth, but there is another option to use a lesser poundage weapon and not as many and still achieve the same effect. Accuracy asks the question, how accurately can the bomb be delivered? This ties back into CEP, or circular error probable, which we discussed earlier. So some of the other questions that can be asked are, what is the weapon's CEP and is it appropriate for the size of this straw hut? Is the straw hut possibly located next to an orphanage? If it is, planners might need to investigate a smaller CEP weapon compared to a larger one in order to not suffer any sort of fallout from accidentally striking the orphanage. Maybe we need to look at, is the hut located in a contested integrated environment? If so, the planners need to consider the JDAM CEP for both GPS and INS guidance. Timeliness asks the question, how long will the lethal effect be in place? So maybe it takes a week to build another straw hut, but bottom line is, how long will it take the enemy to reconstitute the thing that was just taken out? Another question is, how long will it take the munition to actually get to the target? If the straw hut is destroyed, then this might be a trigger for a different action in the battle space. So now that we've completed this lesson, you should be able to list the 4 components of a bomb, summarize the use of a fuse, compare and contrast unguided bombs and precision-guided munitions, and then name a mission planning tool to use for lethal effects for bombs. Here are some more resources for the material. Thanks for coming out to CT today. If you have any questions, please get a hold of me in Mattermost or leave a comment below. And a big thanks again to DOW for helping me out this week and QCing all the products and making sure everything looks sharp. I greatly appreciate it and look forward to teaching you guys in the future.